All right, notification's been made. Recording is in progress. For reference, these recordings are then posted up to the YouTube OWASP SAMM channel, so you can check out some of the prior recordings. And if you have any concerns about the recording right now, I believe it's only recording me unless you speak during the call in my screen. So your presence is not shared in the recording for privacy reasons, but if there are any concerns, you can drop off if you'd like. So anyway, without further ado, the secure deployment is, under the implementation function. It is probably one of those areas that we really want to make sure that we have very specific kind of processes around and instructions when we're building software for organizations, so that the build process is instrumental to making sure that what we're building is and deploying to an environment is consistent with what we've tested, what we've secured, that our artifacts are indeed what we've validated and what are being used in our environments. So it says it's kind of one of the final stages in delivering secure software, and I would say that it is true that it's towards the end of deploying it to the environment. There's still a lot more work to be done, but it definitely is one of the most critical ones. We've got in previous calls, we've talked about secure build and what the build process looks like. So now when we've got an artifact, we want to make sure that when we're deploying it to an environment, we are in fact, focusing on minimizing human error, human interaction, so that we don't break things, we don't introduce risk that should be kept out of those environments accordingly. So it helps ensure the success of what we're building and what we're deploying ultimately is guaranteed. So some of the ways that that's addressed when it comes to stream A with the deployment process is, as you can see here on the screen, is from the various maturity levels. At level 1, we've identified that deployment processes are fully documented. We know that oftentimes in maybe smaller teams or teams with lower maturity levels, a lot of these processes are in the head, say, for example, of an individual within the organization or within the team. And sometimes those processes lack documentation. So we have the scenario of what we may call the lottery problem, or sometimes known as the bus problem, where somebody who's responsible for that process is no longer available within the organization, and it presents a risk of not being able to recreate that what is maybe currently a manual process. So it's critical that as part of that process, we have clearly defined set of instructions of how that process works, so that others in the organization, should they need to pick up that responsibility, have very clear mechanism for doing so, and really from an end-to-end process, so that it can be consistently followed. Ideally, this information is centrally stored and accessible to anyone who needs to have access to it. It ensures that we don't have artifacts being deployed incorrectly in terms of sequence. We don't want, for example, experimental artifacts that may be intended for a subset of our users going to production when they should be going to an experimental environment. So we want to make sure that these things are documented. We want to make sure that the tooling in particular that we're using as well is reviewed and such that they're actively maintained and up to date with security patches. Oftentimes, once a kind of a CI/CD pipeline gets set up, we run the risk of their, not applying the same rigor to that environment or through that tooling that we would maybe apply to the software that we're developing for our customers. But it's important that the same kind of rigor is applied to it, so that it is up to date with security patches, The tools are configured and hardened according to, vendor guidelines as well as industry best practices. Oftentimes, and, one of the primary reasons for that being the case is that, these tools are given access to sensitive environments, particularly the production environment. And so it's very important to ensure that the security there is rigorously applied. We also want to make sure that we have the appropriate access controls in place. So that's another consideration as well. So as we go through and look at the deployment process in detail, just click through to here, maturity level 1, we can see the benefits, limited risk of human error during deployment processes to minimize security issues. And one of the questions that we ask as part of the overall maturity toolkits criteria question is, do you use repeatable deployment processes? So again, some of the quality criteria are listed here. As I mentioned, ensuring that you have enough information to run the deployment process. Ideally, it's automated. Of course, automation takes a lot of effort, and for some small teams, lean teams, young organizations, that's not necessarily the case. It's maybe somewhat manual, or parts of it are manual, and so there is at least enough information for individuals to run the deployment process. That necessitates that documentation for that process is up to date. As I said, it's accessible to relevant stakeholders. Access control, we want to ensure that only defined and qualified personnel can trigger a deployment. So separation of duties there is kind of important, depending on the organization that you're in and regulatory requirements and compliance requirements. This may be a necessity and is the case, but in other areas, in other orgs, that may not be the case. So, a good practice is to not have developers have access to production environments, but I've seen in my experience that in some cases, organizations kind of have adopted more of the DevOps and DevSecOps models where the roles become blurred, and that's not the case. So I would say, you're going to have to, it depends on your organization, but have a good understanding, have that defined, have that auditable in your organization as to who can actually do those deployments. And as I also said, make sure that you're hardening the tools that are used within the deployment process. Your Jenkins tools, if you're running your own type of Jenkins type pipelines, make sure Jenkins is up to date with the latest patches. That's a critical, component there. If you're using, tools like GitHub Actions, make sure that you've gone through the appropriate level of hardening with those. If you're using that, if you're using, the cloud tools like Azure DevOps or AWS Code Deploy, all of which provide really great documentation. And I'll actually share some links that I pulled together to share with you, provide a lot of, very clear guidelines on hardening those environments. So at a level 1, this is kind of the recommendation is ensure that your deployment process, it's fully documented, it's formalized, and that you are securing the tooling. And I'm just going to pause for a second to see if anyone has any comments or questions. All right. And then just jumping into level 2 here, the benefit of level 2 is, deployment processes should include integration with various security tools and milestones, as well as a degree of automation, ideally across all stages of that deployment process, but at least as a best effort in the areas that are going to be the highest risk. So let's see. And yeah. Thank you for that tip there. Sorry, I didn't realize that was in the way. So level 2, the benefit. efficient deployment process with integrated security tools. So, as I mentioned with maturity level 1, if you are fortunate enough to have the resourcing and the capabilities to automate your deployment process, that's great. Level 2, we definitely want to strive towards having that automation in place. So, automating the process across all stages so that manual review, manual interaction with the pipeline is not needed, and human interaction is basically not part of that process, so that human error is minimized and or removed entirely. In this case, eliminated. We want to ensure, that it's a repeatable process, consistently, and reproducible. One of the key recommendations of level 2 is to also start to incorporate some of the security tooling into this phase. So using a DAS tool to scan against an environment that an asset's been deployed to or an artifact's been deployed to, and then verifying the integrity of those deployed artifacts as well is a nice thing to do. Using checksums, for example, is a nice way to ensure that the artifact that's been built and tested and then deployed is the same one along in each environment that you're deploying to. Google has an interesting kind of concept that is really fascinating to me, and it's great. I don't use it, but I've been learning more about it, which is binary authorization, which uses a degree of attestation of the artifact from each phase to the next to ensure that the artifact that you're deploying is the one that should be deployed, has passed previous testing along its journey through the pipeline, and that gives you the assurance that you need that what you have tested and secured along the way is what's making it to your production environment. We can see, in this particular case, there's a series of steps that are taking place, and one of the recommendations is, and requirements really for the quality criteria, is that you're logging the results of these tests centrally, and that you're reviewing the test results and acting upon them so that when defects are identified, the right people can address them and really solve these problems before they become introduced into a production environment. Ideally, you're basically at this point introducing security gates. So if you're identifying issues in your pipeline from that artifact and from that process, you are acting upon a certain degree of them, whether those are, criticals would be the ideal and a minimum level, but also highs, mediums, and depending upon prioritization, bandwidth, and things of that nature, and a review of them, any low findings. I will mention that when we look at the question here, our deployment processes automated and employing security checks, the list of quality criteria, I kind of alluded to that you should be doing them as best practice for the SAMM framework. They're mandatory. So if you're answering these questions and you want to answer them in the affirmative, you're going to want to ensure that your quality criteria is met. So for example, deployment processes are automated on all stages. So at level 2 maturity, your deployment process should be fully automated to all environments. It should also include automated testing, security testing procedures. So not just functional testing, integration testing, and unit testing, but security specific testing. You alert the appropriate staff to identified vulnerabilities, and you have logs available for your past deployments for a defined period of time. So, as you can see, level 2 is you've got a very defined process, and it's a repeatable process. And these are kind of mandatory criteria for you at this phase of the maturity level. But it's ideal. Pipelines are becoming more of a target of attack, so it's increasingly critical that you have that level of assurance and and as a consequence, the maturity to say that you have this security in place. So as it says here, the goal is to account for and audit all deployments to all stages, having a system in place to record each deployment, including information about who conducted it, the software version that was deployed, and any relevant variables specific to the deploy. A lot of the pipelines and tooling available today can provide that to us. Some of those artifacts might include, a software bill of materials. If you can generate that type of artifact as well, that's an excellent outcome and artifact to have available to you in your audit trail. It also certainly helps later on when you're reviewing things and verifying, are we using certain components in our software and things of that nature. They provide you a quick way of reviewing and determining what you're using. So going into level 3, and level 3, this is where we have a repeatable process that is continuously being evaluated for opportunities for improvement. In this particular, and that's kind of a generic statement about level 3 maturities within the SAMM framework. In this particular stream and this practice, the benefit of it is that we have an ensured integrity of our artifacts being deployed to production. So I did allude to it in level 2 that you can verify the integrity with things like MD5s and things of that nature. This is where kind of binary authorization comes into play. So recommended activities to take advantage of binaries being signed at the build time, and then include verification of that signing when it's deployed to the environment by checking the signatures against trusted certificates. Some type of attestation of the artifact that's been pushed to that environment against some other authoritative source. And in this case, it includes binaries not just developed and built in-house, but also any third-party artifacts that you're deploying as well. In this particular case, if an attempt is made to deploy an artifact where signatures can't be verified, then the deployment should fail. So do not deploy those if that happens to be the case. If the list of trusted certificates includes third-party developers, check them periodically. So you should have some way of verifying that those are in line with your organization's governance policies regarding, third-party risk management, third-party suppliers. There is a criteria of here manually approving the deployment at least once during an automated deployment. There is a degree of friction, I think, that's introduced with that, but it's an important part to ensure that the accuracy of your process is validated occasionally, and that you can indeed confirm that there aren't any issues with the process along the way. So the question in this particular stream is, do you consistently validate the integrity of deployed artifacts? And the quality criteria for this one would be you prevent a rollback deployment if you detect an integrity breach. So your checksums don't match, your signatures against certificates don't match, you fail the deployment. The verification is done against signatures created during the build time. So that was, if in the prior practice, secure build, that's one of those things that is an activity that takes place during that process, is to create a signature. This is the opportunity when it's about to be deployed to an environment to verify those signatures. And like in this particular third criteria, if checking of signatures is not possible using, for example, externally built software, you introduce compensating measures. I'm going to just kind of mention that one of the benefits of this, or considerations for this process, is to have the opportunity to do rollbacks. For example, if something fails along that way, Ideally, you're not deploying it to it, but you can roll back to a prior version. We want to make sure that you can have traceability of your artifacts. So, for example, who triggered the deployment process, what was actually introduced into that new build, whether it was done by a commit or a pull request or some other mechanism. It's critical that your logging and audit trail includes that information. At a high level, I'd say, access management, I mentioned that earlier, where separation of duties is kind of important. Make sure that the right person is the one responsible for deploying it. It should only be specific individuals should be allowed to do that to specific environments. For example, you should only be authorized, only a certain individual should perhaps be authorized to deploy to a production environment. There are also, when it comes to the integrity verification, I think there are a few places where it's, it really is important. The integrity of the artifact when it's retrieved and made ready, the integrity of the artifact after deployment to the environment. And if you have a mutable artifact, one that can be modified, the integrity of the configuration instructions as well are an important part of that process. This is going to take us kind of into the next phase, which I think is worth just kind of alluding to. When you have your deployment process, a lot of times there are going to be components of it that require access to other resources, and those resources require some type of authentication. So that leads to the issue of secrets and how secrets are managed in this process. So going back to the high level of this secure deployment practice, we have two streams, stream A, which is a deployment process, and then stream B, which is secrets management. So stream B is kind of focused, these streams are kind of like parallel. They're not necessarily sequential in any way. It's kind of the way that we structured the framework. We had this high level practice and these two streams, which are basically objectives that we want to achieve within the given practice. So we have this deployment process, but a critical part of that deployment process is secrets management. So I'm going to talk a little bit about secrets management in a moment, but I want to just kind of maybe just stop talking for a moment and see if anyone has any questions or comments around deployment process, maybe some feedback on their experience, some tips they may have they'd like to share with others. Anyone? Okay. All right. We're going to continue on then and start to talk a little bit about, secrets management. So with secrets management, what we have here, we want to, at the highest levels of this stream, maturity level 1, we want to introduce basic protection measures to limit access to primarily, but not just production secrets. I think in general, if you have a good process and a good solution for handling secrets, you're going to be able to apply it to all of the environments that are part of that pipeline. At level 2, secrets are injected, dynamically during the deployment process from hardened storages and auditing of all human access to them. So, definitely want to make sure you understand and have a very clear understanding of who actually has access to the secrets within your pipeline and how that's handled. And then for level 3, again, level 2, we have a very clear process for handling secrets. At level 3, we're taking that process and we're continuously inspecting it and improving it. So in level 3, we're improving the life cycle of application secrets by regularly generating them, ensuring proper use. So let's jump into that into a little bit more detail. So here we are with level 1. You want to have your benefit is that you're defining and limiting access to production secrets. At a minimum, developers should not have access to secrets for production environments. I will be the first to admit that in many places I've been at, that is not the case. Developers have superpowers granted to them for better or worse and have access to more things than they should. And that's a reflection in part of the maturity of the organization. So at a minimum, though, at a level 1, you want to make sure that for production, at least, you are not giving those out to developers. Next thing you want to do is make sure you have a mechanism in place to actually adequately protect them. One, by having specific persons adding them to configuration files upon deployment, if that's how it's done, following a separation of duty principle, or by encrypting the production secrets contained in configuration files up front. The different cloud providers, if you're using cloud providers like AWS, you can use Secrets Manager, Systems Manager. There are a number of ways for storing secrets within your cloud environments outside of your code so that they don't become exposed and visible to unauthorized individuals. So next step here is it says do not use production secrets and configuration files for development or testing environments, as such environments may have a significantly lower security posture, and don't keep secrets unprotected in config files stored in code repositories. That last statement there, I think we've probably all read and heard in the news these days about repositories containing a secret and then becoming exposed and a data breach occurring as a result of that. So there are some tools for dealing with that. For example, there's a great project called Get All Secrets, which you can use to run against your repositories, which will find any of the secrets that might be stored in your GitHub repositories. You can run that and find those. That would be an excellent thing for you to do. Highly encourage you to run that if you are using GitHub, for example. Store sensitive credentials and secrets for production systems with encryption at rest at all times. So, and consider a purpose-built tool for this. So, this is where cloud tools, native tooling like Secrets Manager from AWS is a great option for you to use. It also helps handle rotation of secrets as well, but it doesn't. It's not a bespoke or a custom solution. It's something that you can use to inject those secrets at runtime so that you don't have to deal with it. Another great tool, and just one that's available, is not an endorsement or anything, but HashiCorp Vault is another one of those that you can use for dealing with sensitive credentials as well. So the question is, as part of the framework, do you limit access to application secrets according to the least principal privilege, aka developers don't have access to production secrets? The quality criteria to meet are you store those secrets in a secured location, developers do not have access to production secrets, and production secrets are not available in non-production environments. That last one, I just kind of emphasize, don't use the same secret in each environment. It happens and it causes havoc when somebody unauthorized or bad actor finds it and uses it against you. So be mindful of that. So going into maturity level 2, I would say, call this, mindfulness of leaks. So detection of potential leakage of production secrets. Having an automated process to add credentials and secrets to your config files during the process to respective stages. This is where that tooling comes into play. And this way, developers and deployers do not see or handle those sensitive values. So there's no visibility to the password in a username, password kind of scenario, or service account and password scenario. No one sees them. Only the tooling knows of them, and that doesn't change. Implement checks that detect presence of secrets in code, repos, and files, and run them periodically. So get all secrets. A good example of a tool, Truffle Hog is another. You can have these tools run through your repositories and have them, find accidental commits of secrets or something that looks like a secret. Maybe it's an API key or some other kind of secret that should not be there. So run those tools occasionally or regularly. And as it says, configure them to look for known strings that looks like a secret, unknown high entropy strings. Really anything that looks like a secret probably shouldn't be in there, and it's worth flagging it and reviewing it for validation. And of course, remove them as soon as you can. Being mindful, as it says here, if you can, removing them from a historic file as well. So your build history in GitHub or other repository tools, they're going to contain these historic commits, and you have to be mindful of not just removing from active code, but also that historic from the historic commits and the history of that file. So that can be a big risk. So be mindful of that. And also, at the same time, if you find that you've accidentally committed a secret to an environment, or if a secret has been divulged, rotate the secret so that way it's not known any longer by any unauthorized system or person. And then make the system use to store and process secrets and credentials robust from a security perspective. So encryption at rest and in transit, of course, applies to the secrets. Understand access control. Users who configure the system should be subject to the principle of least privilege. So make sure that whatever solution you're using has good role-based access control. And in this case, an example, a developer might need to manage secrets for a development environment, but not for a user acceptance test or a production environment. So keep that the case for this as well. So do you inject production secrets into configuration files during deployment? Source code files no longer contain active application secrets required. Under normal circumstances, no humans access secrets during deployment procedures is required. And you log an alert to any abnormal access to secrets. So if an unauthorized individual or source system accesses that secret, you should know about it almost immediately, and you react to it accordingly and address it. So let's go on to level 3. And so in this particular one, again, we've got a well-defined process from maturity level 2. Now we're continuously inspecting it and improving it, which is, again, the pattern of the framework. And level 3, when you're dealing with secrets management, you minimize the possibility and timely detection of production secret abuse. Again, we talked about that a little bit in level 2. In this case, you have a very clearly defined lifecycle management process for production secrets, and you ensure generation of new secrets as much as possible, so that you're not, for example, reusing secrets. You're not having secrets that have been around for too long of a time, and really for every application instance that exists, it has a unique secret. The use of these unique secrets per application ensures that weird application behavior can be traced back and analyzed, so we have an audit trail, and there are tools that can help automatically and seamlessly update those in all places upon change. So secrets manager, part of your pipeline, you can ensure that those secrets are injected upon runtime and not during build. which would not be a good practice. You also ensure that all access to secrets is logged in a central infrastructure. Again, I won't mention those tools anymore, but you have an ability to review logs to identify, anomalous behavior, unexpected behavior, and to really know why that happened. That includes, obviously includes audit logging. Some other mechanisms that you might use are tools like canary tokens, which seem to be coming, and others on this call may have actually worked with them already, but they seem to be becoming increasingly recommended. I haven't used them myself, but I've learned a bit about them, and they do seem like a good idea, where you, like a canary in a coal mine, for those of you who have heard of that term, you can know when something has touched it, something has accessed it. Let's see. Someone's asking a question. Can you elaborate on the prepare activity, define the scope? I'm not sure what factors I should take into account for choosing team or product scope. So yeah, we can talk about that. I'll add that to question. I'm going to just go through this last bit of criteria, and then we'll take some Q&A. So for maturity level 3, for secrets management, do you practice proper lifecycle management for application secrets? So you generate and synchronize secrets using a vetted solution, not necessarily homegrown. Secrets are different between different application instances, and secrets are regularly updated. You may have maybe an authentication standard in your organization that defines the rotation of username and passwords, things of that nature. You may not exactly identify, for example, system service accounts or APIs or other things. So definitely consider them in the controls within your organization to ensure that secrets are regularly updated at some cadence. 180 days is fairly common, as an example, but I would use a risk-based approach, and depending upon sensitivity of the data that it's protecting, you may want to increase that to 90 days or even 30 days. Rotate them as often as possible. And really, I'm going to emphasize, don't reuse secrets. Make them, temporal. They should not be around for any long period of time. Make sure that they're kind of ephemeral. They'll go once they're used, and their use is done, they're never used again. So it's an important part of it. So that's kind of the two streams of the secure deployment practice. I know I kind of crammed a lot into this in the short time that we have today, but I'm going to stop recording now and open it up for discussion, so that folks can feel comfortable asking whatever they'd like. So let's see.